Hey, what's going on YouTube? This is the ElementalMaker, and today we're going to be putting together the electronics for a Grizzly G0704 milling machine that we're converting over to CNC. Alright, so the first step in building this machine was really figuring out the electronics, exactly what I was going to be using. And I came across a guy named Haas on the forums. He was very helpful. Pointed me towards a company called Automation Technolgies for the electronics. So here we have the power supply. This is a 48 volt, I believe. Yep, 48 volt, 12.5 amp power supply. So I'll take that out a little bit later. Here we have the, I believe that's the C10 breakout board, drivers, power supply, little one, our Nema 23s, and then our Nema 34 over here. So I'll start with this sucker. This is a beefy motor. Not something to play around with here. Really pretty nicely made. I can't really detect any major blemishes on it. Looks to be a good unit. So we'll see how that sucker handles the Z-axis. Now the Z-axis is the heaviest part of the mill to control. Quite a few guys put I think air pistons on them, similar to what you find in the back of like SUVs on the lift gate. Here, popping some bubble wrap. Here we have the first Nema 23, my stepper motor. This is a 570 ounce-inch stepper, I believe. The Nema 23 is 1200 ounce-inch. And we just have another one of these Nema 23s here. So there we go. There's our two Nema 23s. We've got the Nema 34. This is a little 5 volt power supply. That's just the power of the C10 breakout board. I won't bother with that. So I ended up going with the Keling Drivers. I was really looking at the Gecko drives. They looked exceptionally easy, but the issue was they just couldn't handle the amount of current I was going to be putting through them. A lot of people have done this build using the Gecko drives, but I just wasn't too comfortable pushing them that hard. So I ended up going with the Keling Drivers, which should be significantly more power friendly, I should say. So, there's some pretty nice heat sinks mounted on the back. That's really good to see. I'm pretty happy with that. Looks like some good electronics inside. They're pretty nicely made. I'm pretty impressed with that for the price they cost. That's impressive. I mean, time will tell how good they are, but from what Haas said and what I was told from Automation Technolgies, these are the drivers to get when you're talking high power. Well, at least high power for this milling machine. So this is the Keling 8070D driver. So this one handles a bit more current, which is going to be used for the Nema 34. These two smaller ones here, the 5056Ds, they're going to be used for the 570 ounce steppers. We have the C10 breakout board here, which in the meantime I'm just going to keep in the bubble wrap. I don't want to, potentially hurt it while it's just sitting here. And then we have the beefy guy, the big power supply. Pretty nice unit. Ooh, that storm is rolling out there. If you can hear that, I apologize. Mother Nature's a little pissed off tonight. But yeah, nice switch mode power supply here. This is a model SE-600-48. Again, it's 48 volts, 12.5 amps. This should be plenty to power my mill, or at least just the drivers to it. Eventually, I'm probably also going to put in a separate DC spindle, which you can control off the C10 breakout board there. I'll probably have to get another separate power supply for that because the voltages are different and you know, it's not going to quite line up. Plus this won't have enough current to power all these motors plus a spindle. So these are the basic electronics you'll need to get up and running with your G0704 milling machine. They're reasonably affordable. I think the whole kit was about 700 some, which really isn't too bad considering the amount of you know, technology and power you're getting for that price. So let's get started with the build. So here we are with the electronics, and we're going to start wiring her up. Very helpful to have a wire kit like this. I want to give myself enough length so that I can use it in the final enclosure it's going to be kept in. Now I only have solid stranded wire here. I would prefer, or solid core wire. I would prefer here to be using stranded, just because it is a bit more reliable. But the good thing is this is going to be in an enclosure, it's not going to be moved often. For the stepper cables themselves, you want to be sure they are stranded because they're going to be incurring a lot of movement, and throughout that, you know, there's always the potential for a solid core wire to just eventually work harden and it'll snap, and then you're gonna, you know, get intermittent working and all sorts of issues, and it's just not going to go well. So make sure you shoot for stranded wire. Whoops, wrong spot already. So the blue wire, number 1, is in place there, and we're going to put that to the pull minus. It's nice and tight in there. So then 2 is going to be red. So I have these secured down. I probably should have secured down the breakout board as well, just because that's going to be kind of flip-flopping around while I'm working on it. It'll get pretty tiring pretty quick. Alright, so we can see here on the diagram, it's probably a bit too small for you guys to see, but the red from the comm pin is going to the, what is that, the pull plus and the direction plus. So we're going to bridge that across these two here. So let's grab a little bit of red for a bridge wire here. And this is pretty much the same step throughout all 3 axes. Basically just following your good wiring diagram, double checking your connections, making sure everything's good. You want to make sure, you know, you have everything in place before you connect power and potentially fry something. Oh, there we go. Yep, barely. Got it. So we're bridging the pull plus and the direction plus here. It's nice and secure. Alright, we're good there. So then we're going to take our yellow, connect that to pin 3. And I'm dropping it. This one goes to pin 3. Trim that a little bit, a little too long. Don't want too much stick out because then you could have wires potentially bumping into one another, and then you're just going to have a really messed up system. So that's looking good. That is going to go to the direction minus. Alright, so those are all in there. And now I'm just going to go through and complete this on all 3 axes here, just to save a little time, so you guys don't have to sit through the bore of that whole thing. Now we're going to wire up the power supply. So here we have the 48 volt 12.5 amp power supply. Oh, that's interesting. It actually, oh okay, never mind. I was going to say it produces more current on 120, but that is the input. It is consuming more current. I was going to say that doesn't make sense. Alright, so here I have some pretty heavy duty stranded wire. This is 14 gauge. I think the brand is Southwire. It's rated for 120, and I think actually quite above that. I could probably take a look here. Yep, 600 volts. Gasoline, oil resistant. It's pretty good wire, stranded, so you don't have to worry about issues there with, you know, wires potentially work hardening and breaking off. So same thing here. I'm just going to wire up one of them. It's pretty easy, and then I'll just fast forward right on through. So we got our V minus there, V plus. So this whole side here is V minus. This is all V plus. So I'm just going to loosen up all these terminals here. That one is in there. Alright, so here's our first V plus. Nice and on there. Now, some guys will actually daisy chain these. So basically they'll just run power to one of them and then daisy chain it over to the next few. I've kind of always leaned against that because if you have one issue, then it's going to propagate to all the others. And you're also running a lot more current through each line, whereas here, you know, each driver here is getting its own, you know, line for maximizing current. I don't think this wire would ever potentially, you know, heat up to the point where it could melt the insulation or cause issues, but just out of safety's sake, you know, it's good practice. So try and stick with the good practices. So you can see these wires are a little excessively long. I figured, you know, better to go long at this point than too short. I do have a whole lot of extra wire, so it's really not a big concern. I apologize for the kind of messy look this may have with, you know, the tediously long wires. All right, let's fast forward through this sucker. Alright, so at this point we're ready to actually wire up the stepper motors. Very useful to find the data sheets for your steppers so you can actually see the wiring layout. So here we have the wiring layout for the Nema 34, which is our Z-axis. So we know yellow is going to be going to the A+, which is over here. Green's going to the A-, which is the next one down. Red is going to B+, which is the third from positive, and white is going to be minus, which is the last terminal here. Now on the Nema 23s, it's actually a different layout. You can see they kind of laid out for you right there. Black to A+, green to A-, red to B+, blue to B-. So it's pretty easy. We'll just wire up the 34, the Nema 34, and maybe get the sucker powered up tonight. Trying to untangle this mess here. I'm pretty surprised with this large motor here. The gauge of the wire seems pretty small, which could potentially cause some heating of the wire just due to its higher resistance. I don't think with these sort of runs it's really going to be any kind of issue, but I would have liked to see maybe I think this is 18 gauge here. I would have liked to see 14 on this. I think that would have been a little more appropriate for the current this motor draws. But at the same time, it's drawing it in steps, so it is dispersed over a greater period of time. It's not at that full amount of current. So green to A-, whoosh. Right. There we go. Red to B+, B+. Which is fantastic. But at the same time, you're kind of used to having your accounts, and let's see, summer, it changes up or down. So I apologize, you're not using hands-on, now it's just, probably, obviously, I think the backseat. So again, if you're happy, you can I'll use it definitely. No, we have tracks, other things. So we're going to be features and wires, and that's pretty much it for the wiring. There are a few things to note with your pins here. This is, from my understanding, basically negatively biasing the board. So you want to connect your jumper pins here for pins 2 to 9. You want the jumper to bridge 2 and 3 and 2 and 3. Now up here you want the pins for the in-out to bridge 2 and 1. And then for this lower pin you want, can't get a good look there, you want it to bridge 1 and 2. So, and that is your inputs. Alright, so at this point I think I'm going to power it up, test the steppers out, make sure everything's working. I got to get the computer set up, so I will be right back. So we have everything hooked up. We have a Mach 3 running over there. Quick zoom in. I have the jog control on. Let's bring her back over. So you can see the motors. Alright, so what I'll do here is just jog the motors a bit. There is some configuration you have to go through with the C10 breakout board. It's very, very simple, and I'll show you how to do that shortly. But let's just give these a quick jog. So there's our Z. There's our Y. And there's our X. Working perfect. Sweet system. Pretty damn cool. Not too bad at all to wire up. Took maybe an hour. Pretty awesome. Alright, hope you enjoyed the video on putting together the basics of the electronics. Join me on the next video where I'm going to put together the control box, get everything nice and tight in here, some fans, some cooling, a lot of mounting, good bit of soldering to do. But very fun project, took a couple days. So make sure you like, subscribe, rate, comment, whatever you want to do. Thank you very much for watching.